All right, so this is the last video for chapter 5. We're looking at applications of periodic functions here. So in this question, we've got, we're looking at the depth of water. So at a seaport, the depth of water h meters at a time t hours during a certain day is given by this formula. So we have this formula here, and you notice I'm going to rewrite it a little bit, just slightly, so that the 12.4 appears underneath the 2 pi, and you can kind of see this part a little bit better. You can see the c shift a little bit better, and this is actually all part of the b value here. Okay, it wants you to state the period, amplitude, and the phase shift. So if we look here, the period is fairly easy to see. It's after after I've written it like this. We take our 2 pi, divide it by the b value, work through that, and we end up with 12.4 hours. So that means one full cycle occurs. So one full cycle occurs in 12.4 hours. So that's from here to here. And my amplitude is 1.8. That's the a value there. And c is the phase shift here. It's my 4 hours. So if I were to have the regular sine function, it would start right from my 0 line here. But since I have a 4 hour shift, I move everything over this way to the right, 4 hours. And then normally I would have, without the shift, I would end up at 12.4. But in this case, I end up at 16.4. So between 4 hours and 16.4 hours, that is one entire full cycle occurring. All right. So now it asks, what is the maximum depth and when does it occur? All right, so the max depth is my midline plus my amplitude, and that's 4.9. So this right here is 4.9. That's the maximum depth that the water reaches. Now, when does that occur? So this is the part you have to think a little bit about. I drew this so that I could help with my thinking. 16.4 hours ended up here, and I wanted my max. So this is my max here. What I did was I thought, okay, my period is 12.4 hours. Halfway from here to here, if I go backwards half, that's going to be 6.2 hours. And then I went 6.2 hours back, and I ended up at my 4. Okay, so that means between 4 and 10.2, the halfway mark is going to be 3.1 hours. So this is how I got my 7.1. And then I did the same thing to get this 13.3. I went 10.2 plus 3.1 hours to get my minimum there. So at 7.1 hours, that is when my maximum depth occurs. Now, I can also say that it's at 7:06 a.m. And in order to get that 06 a.m., all I did was take this 0.1 hours and I multiplied it by 60 to get the number of minutes. Okay, now, what is the depth of the water at 5 a.m.? Well, all you have to do for this is let t equals 5 a.m. and solve. So you're substituting it into the given equation and getting your answer. All right, so that means that it's we end up with 3.97354 meters approximately, and we're looking at this tidal wave. So it's you know, it begins normal, the water moves down, it moves back to normal, and then back high up again. Okay, and it just continues on that way. All right, so now our example on the next page has to do with a tsunami. So a tsunami is a very fast-moving ocean wave that's caused by earthquakes, and it occurs. These earthquakes occur underwater. Now, the water will first move down from its normal level, then move an equal distance above the normal level, then finally back to the normal level. Okay, so you can kind of see the pattern here, right? It goes down and then back up again. The period of the tsunami that we're talking about is 16 minutes with an amplitude of 8 meters. The normal depth of the water at Crescent Beach is 6 meters. So this 16 minutes gives us our period, and the normal, that is our D value. That's going to be our 6 meters. So if we look here, normal is 6, our amplitude is 8, so our max is 14, and our minimum is -2. So that means it's actually below 0, so the water isn't there anymore. It's way far back away, and pretty dry once you have -2 meters of water. So I drew this just to give me an idea, but since the water moves away first and then goes back up, it's actually a negative sign function. All right, now, so write a sinusoidal function to represent the tsunami when it first reaches Crescent Beach. So I've got my A value and my D value. I've got my period. So my period, I need to figure out a little more information about. I need my B value. So my period is 16 minutes. That's equal to 2 pi over B. To get my B value ends up being pi by 8. Now, since the water moves down first, this is a y equals negative sign function. All right. So my A value in this case isn't going to be 8. I'm going to write it down as -8. And here is my B value. I can put a bracket in there just for, well, why not? And a +6. So this is my midline here. All right. So there you have it. Now the rest is for you to do. I am done with chapter 5 videos. You can rejoice. You have no more to watch. And it's now your turn to actually do questions. So make sure you do as many questions as you possibly can. And if you're getting stuck, make sure you ask for help. All right, take it easy. Enjoy.